Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about input and transfer impedance. So input impedance of a line is measured at the input terminals. So consider the transmission line having the length L and characteristic impedance Z0. So we are going to measure the input impedance Z in. So input impedance is defined as the impedance measured across the input terminals of the transmission lines. It is impedance seen looking into the sending end or the input terminals. It is also the impedance at the input into which the source must work when the line is connected. Also known as the driving point impedance, it is denoted by Z in equal to Vs divided by Is. We are going to find the standard form of input impedance. So first form is given in the voltage and current expressions of hyperbolic form. For example, in the first equation, voltage is given where it is E or cos h of square root of Zys and I or Z0 sin h of square root of Zys, where E r and I r are the receiving end voltage and currents and the square root of Zy is the characteristic impedance and it is given in hyperbolic form. Similarly, current expression is given in the second equation. So we are going to find the input voltage and input current for the transmission line of length L. So replace S by L and square root of Zy by gamma and replace E by Es and I by Is in equations 1 and 2. So these are the changes to be done. So we get the input voltage and input current. So from finding the input impedance, divide Es divided by Is. So from the previous equations we get EZS value. So it is one of the standard forms of input impedance of a transmission line. So in this equation, gamma is the characteristic propagation constant and second form of input impedance. So for this we are taking the voltage and current expression standard forms in terms of impedance values. So to find the input voltage and input current, we are going to replace the S value by L and square root of Zy by gamma and E by Es and I by Is. So after that, dividing the E by I value, we get Z in terms of ZR and Z0. So this is the another form of input impedance of a transmission line. So the previous equation, hyperbolic equation, is modified in terms of tan H. So for a lossless transmission line, the input impedance is purely imaginary. That is, gamma value is taken as J beta. So the expression of tan H gamma L is modified to tan of beta L in this expression. So where beta is the 2 pi by lambda, it is the wave number. Activity. So this is solved using the distance and time problem. Input impedance of a special cases of line matched load. So when another special case is when load impedance is equal to the characteristic impedance of the line, that is the line is matched. So the impedance reduces to the characteristic impedance of the line. So that is it is equal to Z0. And next is short line. So shorted line is ZL equal to 0. The input impedance is purely imaginary and the periodic function of the position and wavelength or frequency. An infinite line, when the length of the line is infinite, so L approaches infinity, Zin equal to Z0. So it is concluded that a line of infinite length irrespective of type of terminating load has an input impedance Z0. So it is behaving like a line of finite length terminated in its characteristic impedance Z0. Next is transfer impedance. So transfer impedance is calculated using the ratio of input voltage to receiving end current. So input voltage of the transmission line is taken and we are substituting the K value, that is the reflection coefficient ZR minus Z0 divided by ZR plus Z0, and then we get transfer impedance ES by IR. So it is derived in the hyperbolic form of using cos h square root of zy into s plus z naught sin h square root of zy into s. So where z naught is the characteristic impedance, zr is the load impedance. So assessment. So define the input impedance of a transmission line. Give the standard form of input impedance. What is infinite line? Compare the input impedance of half wave and quarter wave lines. What is transfer impedance? So thank you for listening this lecture.